Plastic pollution is one of the most urgent environmental issues we face today. Since the 1950s, over 9 billion tons of plastic have been produced, but only a small percentage is recycled. The rest pollutes our land and oceans for hundreds of years. Many single-use plastics, especially in packaging, are used just for minutes but remain in the environment for lifetimes. That is why we decided to create something better, a plastic that works well and breaks down naturally. Welcome to our presentation on Eco-friendly CoCa-Plastic, an innovative bioplastic developed from coconut husk and cassava peel. This project aims to tackle plastic pollution by turning agricultural waste into a valuable biodegradable material. Our innovation, CoCa-Plastic, is made from cassava peel and coconut husk, two agricultural wastes that are often discarded. We transform these materials into a useful and eco-friendly plastic. Traditional plastics are made from the fossil fuels and they don't break down in nature. Some bioplastics already exist, but they often require expensive industrial composting and are not strong enough for practical use. At the same time, agricultural waste like cassava peels is rich in starch, which is perfect for making biodegradable plastic, and coconut husk is strong and fibrous, ideal for reinforcing the plastic. By combining these two materials, we created CoCa-Plastic, a strong and biodegradable material that helps reduce pollution while turning waste into value.
Development of CoCa-Plastic.
Our raw materials were cassava peels and coconut husk fibers, both abundant agro-waste. We prepared the cassava starch by washing, drying, and grinding the peels. The mixture included cassava starch, aloe vera gel as a natural plasticizer, and gelatin as a binder. Steps to make a bioplastic from cassava peel waste. The first one is preparing the cassava peels. The cassava peels are cleaned to remove the dirt, then dried to get rid of moisture. After that, they are ground into a fine pulp. This helps get as much starch as possible, which is important for making the bioplastic. Drying. The molds are dried in an oven at 70 degrees Celsius for 24 hours. This step turns the mixture into solid sheets and makes sure all the samples have similar strength and quality. Next, we mix 10 grams of cassava starch, 75 ml of distilled water, some aloe vera gel, and 200 ml of gelatin. The mixture is heated and stirred until it becomes thick and smooth. Heating helps blend everything well. Once the mixture is ready, it is put into molds for tests like biodegradability, water absorption, and strength. To test how the fibers affect the plastic, some samples are made without the fiber and others are mixed with small amounts of fiber, which is 0.1 gram, 0.2 gram, and 0.3 gram. This will help the researchers to see if the fiber improved the bioplastic. Strength. The results showed a clear correlation between fiber content and the strength. As we increased the amount of coconut husk, the strength of the CoCa-Plastic improved significantly. The 0.3 gram fiber sample was the strongest. This is due to the presence of lignin and cellulose in the coconut husk, which are known to enhance structural integrity. The fibrous network distributes stress better, making the plastic more durable. This suggests that CoCa-Plastic with a higher fiber content could be suitable for heavier duty uses like trays or pots. Water absorption. The more fiber we added, the more water the plastic absorbed. Coconut husk is hydrophilic, meaning it naturally attracts and retains water. The 0.3 gram sample showed the highest water absorption, which could affect the plastic's performance in humid environments. Therefore, for applications like food packaging or moisture-sensitive products, lower fiber content might be more appropriate. Biodegradability. Another interesting finding was the rate of degradation. The plastic with no fiber degraded the fastest, losing nearly 4% of its mass in just 10 days. The 0.3 gram fiber sample degraded the slowest. This is because lignin in the coconut husk is resistant to microbial breakdown. It forms a rigid barrier that slows the decomposition process. This is a key insight. While aiding fiber makes the plastic stronger, it also makes it more persistent in the environment. Copyright Certificate. We are proud to share that our product, Eco-friendly CoCa-Plastic, has been officially registered with MyIPO, the Intellectual Property Corporation of Malaysia. Novelty and advantages. What makes CoCa-Plastic special is its unique combination of features. First, it uses inedible agricultural waste, cassava peel for starch, and coconut husk for fiber, turning waste into a useful product. It replaces chemical plasticizers like glycerol with aloe vera gel, a safer and natural option. It does not require any industrial composting facilities. It breaks down naturally in the soil. It replaces synthetic plasticizers with aloe vera gel, a natural biodegradable substance. It's 100% compostable, posing no harm to the environment. Unlike some bioplastics that depend on commercial crops, CoCa-Plastic supports sustainability without taking away food resources. It is part of the waste to wealth movement, where unwanted materials are transformed into valuable eco-friendly products. Conclusion: CoCa-Plastic is a promising solution to the plastic pollution problem. It combines strength and sustainability using natural materials that are widely available. Our research proves that with the right combination of cassava starch and coconut fiber, we can create a material that serves its purpose and returns to the earth safely when its job is done. Commercialization. The commercial potential of CoCa-Plastic is strong. Its ingredients, cassava peel, coconut husk, and aloe vera, are cheap and widely available, making production cost-effective. The process is simple, requiring only basic equipment. Small businesses, schools, and even communities could produce their own CoCa-Plastic for local use. It can be molded into food containers, seedling trays, biodegradable packaging, and more. As sustainability becomes a priority worldwide, eco-products like these are gaining popularity. CoCa-Plastic offers a practical, low-cost, and green solution that fits the needs of both consumers and environment. With proper investment, it has potential to enter markets that are actively seeking alternatives to conventional plastic, from agriculture to retail. Acknowledgement. I thank Technology City Amina, my supervisor, for her valuable guidance. Your support made this research possible. Our research builds on global studies related to the plastic pollution, eco-waste valorization, and bio-based polymer science. Detailed references are listed at the end of this presentation.